Time is 7 o'clock, so let us start on time. And I'm sure that other participants would join shortly because many have colleges and they come little late. So it's we can understand. Thank you once again. And on behalf of MTC Global Family, I extend a hearty welcome to all the participants. We already have with us Dr. Murugappan sir, who is the resource person for this particular workshop. And it's a great pleasure to introduce briefly Dr. Murugappan sir for the participants to understand. Dr. S. Murugappan has over 8 years of experience in industry and 25 years of teaching and research. He is an expert in model building, simulation, data analytics, design of experiments, and statistical applications using SPSS, R programming, visual analytics using Tableau, Power BI, and advanced MS Excel. He strongly believes in imparting concepts through case analysis and hands-on experience by means of model building. He has conducted research work on the impact of floating interest rate on home loans, a simulation study. He has published several research papers in the Journal of Repute and presented many papers in conferences. At present, he is guiding several doctoral research projects. He has rolled out workshop on exploring data using pivot table for the industry people and research scholars. He has been a consultant in the fields of finance and market research. He has been a resource person for various management development programs conducted for the executives of various organizations. He has a passion for conducting business application software training program. His areas of interest are research methods, business analytics, data mining, visual analytics, financial modeling, security analysis, and portfolio analysis, merchant banking and financial services, fintech as well. So it's a great pleasure because he's currently professor and director, Bannari Amman Institute of Management. So Satyamangala. It's a great pleasure to have sir. And instead of his busy schedule, when I approached him, sir has immediately agreed, to be the resource person. Thank you so much, sir. I request you kindly please take over the session. Thank you once again.
Thank you, sir. Thank you so much for the nice introduction. I hope my voice is audible. And
Yes,
now
sir.
I am presenting my screen. I hope my screen is visible now. I hope.
Yes. Right, sir.
Right, sir. Before starting this session, I would like to brief about the topic. When Sir has approached me to conduct a workshop on visual analytics, I thought of taking the software Excel and as well as a Tableau. Both the tools are very versatile as well as user friendly, and moreover, the Excel is a one everybody can access it. Tableau also we can access it, but again it's a licensed version. But Excel is everywhere, so I am concentrating both on Excel and as well as a Tableau. Once if we are comfortable with this two software, any software just like that, migrating from Android to iOS or iOS to Android, how we are migrating it seamlessly. Similarly, then again we can also then again equip ourselves with other softwares also. So I would like to start with some basic fundamental concepts as we stated in the then again brochures. Then again all the topics I'm trying to cover with a small introductory note on the concepts. I hope my slide is visible for every one of you. Yes? My slide is visible
Yes,
for
sir.
every
Yes,
one
sir.
of you?
Yes, sir.
Right, okay. So I'm starting with the concepts. First, the concept dimension versus measures. Understanding these two concepts will help us to construct the graphs seamlessly. Already known concepts, but again, I would like to recap and then I can re-emphasize that particular concept. Dimension and the measures, there are two, then again, variables. This is one of the classification. There are n number of ways the variables can be classified. The one way of classifying the variable is dimensions versus measures. Measure is nothing but, sir, it is a quantitative variable. Numeric numbers, all numeric values we may call it as a measure. Measures predominantly that it will be treated as a dependent variable. Whenever you are taking it into analysis, we are taking the quantitative value. Even in the regression, you are trying to then again predict the movement of the sales based on the advertisements. Like predominantly, the dependent variable will be a then again measure. Sometimes that may be the categorical variable or a dimension also. Maybe, yes, the discriminant analysis is a one example. Logistics regression is another example, then again I can quote. Then, simply I can say that the dependent variable or the measure's value is a function of one or more dimensions. So, for example, I can say that then again, the performance of this class in terms of marks, it's a function of then again the difficulty of the subjects. The difficulty of the subjects, I can say that then again it's a too difficult, moderate, easy subjects. So here the moderate, difficult, very difficult are all dimensions. That is a categorical variable. Then in Tableau, when we are then again taking the numeric values, always we are considering it as a measure. In a simple term, I can say that measure is nothing but it is a quantitative data or a numeric value. Okay, always it is called as a dependent variable. Second, I am coming to the dimension. Dimension, simply I can say that it is an independent variable. And again, I can say that it is a categorical variable. It is a categorical or qualitative data. We can say that it's a quality. Now, why I am saying or why I am covering all the alternative names, because each and every context, the people are using different names. We should not get disturbed. So that is why then again, I'm using the alternative names also. Generally, we can say that the measure is a number. The dimension is what we would like to slice and dice the number. For example, I can say that in the program, how many number of people are male members or female members? Like, so the number of participants is a number. Then again, I'm slicing and dicing the data by the gender. Like similarly, in number of examples I can quote. Then next, I am moving upon discrete versus continuous. I hope all of you can remember in the school days itself, we are covering that particular concept, discrete versus continuous. Discrete variable is nothing but it is a second big way of classifying the data into the Tableau. And not necessarily in Tableau, even in Excel, then again, transparently or explicitly, we are not saying it is a discrete, but again, we should understand the data has been classified as a discrete. Then the discrete variable, again, I can say that it's an example as a color, I can say. Okay. And the classification as an important here on what type of visualizations we can create. That is very important. It is a discrete means a different kind of a visualizations. If it is a continuous variable, it's a different kind of a visualization. Continuous variable, again, I can say that it may take any value. So for example, here we can say that a height is an example I can quote here, that it may take any value in between. But the discrete values are all having the values, and in between that does not have any value. Say for example, here the number of children, and I can say the number of children, I can say that 0, 1, 2, 3, 4, 5. Like I can say the whole numbers alone. but I can't never say that I'm having an 100 of children or 1.75 children. So the number of children here, even though it is a numeric variable, that is called as a discrete variable. Even if it is a, then again, it's a dimension, it's a qualitative data. Again, in Tableau, we are classifying it as a discrete versus continuous. Let us see that one appropriately at the time of that particular, the examples and all other things. And again, this discrete continuous has been identified by the colors in Tableau. The blue color indicates it's a discrete and the green color indicates continuous. System will identify, even if it is necessary, we may change also. Okay. Once again, I'm repeating, the discrete variable does not have any continuous values, but the continuous variable have a continuous values as the name stated. The best example is the height, or liter or kilogram or whatever may be, or even if you are taking it's a gold weight, we may say that 1.75 grams. Then again, that may take any values, 1.75, 1.74, like 2 digits or 3 digits or whatever may be, that it may take any value. But as far as the discrete is concerned, that it's always have a whole numbers, like number of children, number of fans in the hall, number of windows in the hall, like a number of example here I can quote here. Okay. So again, in the discrete versus continuous, the two rule of thumb we can have it, or we may consider it, or we may keep it in our mind. Always the discrete variables are all in x-axis, the continuous variables are all in y-axis, because whenever we are talking about visual presentations, we have to talk about the x-axis, y-axis. So all the discrete variables will comes into the x-axis, and the y-axis always that it contains a continuous variable. The discrete fields can be sorted, but the continuous fields cannot be sorted. That have its own chronological order. That may have an ascending order or a descending order. That's all. You can't sort it. But the discrete variable, then again, any kind of a thing, then again you can say from the, say for example here, the colors, if you are taking it, any positions, then again you can keep it here. So for example, you are having a yellow, green color, red color, like you are constructing a chart, then again, either yellow alphabets, you can arrange it, or any kind of a sorting is possible. But here sorting is not possible. Okay. Right. This is one example I can quote here, the discrete and continuous. In the display, the first display is a discrete variable. Here in x-axis, when you are seeing it, January, February, March, April, that it contains the entire year's January month, entire year's February month, everything. But the same data set, I'm using it in the next graph as a continuous variable. Please see here, in this pointer here, please see here, the pointer. And the 2012 to 2013, the data points are there, 12 months data points are there, and chronologically that it has been ordered. 2012 January, 2013 January, both are in a different position. But here, the 2012, 2013, 14, 15, 16 Januaries are all combined together, and that it has been shown as a one single bar here. Okay. So the discrete variable, when you are using it, then again the sorting is possible here. You can sort it either the lowest to highest value, or either alphabets based on that particular the number of the month's name, or based on the calendar. Then again you can sort it. Any kind of a sorting is possible when you are using the discrete variable. But here in the second graph, the month of order date, here you can't sort it. Either you can keep the value from 2016 to 12 or 12 to 16. That's only the two way you can keep that particular visualization. Right. Now I'm coming back to the first. So we started with the presentations, dimensions versus measures. Dimensions is nothing but it is a independent variable that it will be used to slice and dice the numbers, and the measures is a dependent variable. Always it is a numeric variable. Right. The next one is a discrete versus continuous variable. The discrete will have a whole numbers. Example, number of doors, number of systems, number of pen, number of mouse, like anything, I can quote it as a discrete variable. But as far as a continuous variable, height, weight, okay, litter, any kind of a metric measurements, I can say that it is a continuous variable. The continuous variables are all denoted by the green colors in Tableau, and discrete variables are denoted by the blue colors. And the impact of this discrete and continuous are have a huge impact on the visualization. That is also very, very important. With the help of a small graphical representations, I'm trying to express the impact of the discrete and versus continuous. Before that, simply we can say that discrete field draw headers, meaning the x-axis will occupy the discrete variable, the y-axis will occupy the continuous variable. The discrete fields or discrete variable can be sorted, but continuous fields cannot be sorted by any value or any criteria, right? This is an example here. Discrete variable, January, February, the month wise I am showcasing here. Here there is no chronological order. Either I can order it January to December. Suppose if I'm sticking with the financial year, I can start with the April, ends with the March, or alphabets also. Then again, I can start with, if that is the case, April is the first month, August is the second month. Like then again, based on the alphabets also, I can sort it, or based on the sales value also, I can sort it when I am using the variable month variable as a discrete. At the same month, when I'm using it as a continuous variable, see here, 2012, 13, in between 12 months data points has been plotted here, and each and every dots represents each and every month sales, and the order is a matters here. You can't change. You can't change. Either you can say that the data visualization from 2016 to 12 or 2012 to 16. That's all. But in between, you can't change the order. The chronological order is a matter secure. Here I'm stopping for the discussion. All of you are clear about this two concepts. Already we have learned the concepts. Once again, I would like to re-emphasize that one, to recap that one, because we have to use that particular concepts while we are constructing the graphs. After covering the two more concepts, then again we can jump into the various graphs that it can be constructed using Excel as well as Tableau. The live examples I am taking the is small data set. With that, then again we can see how we can construct the different type of graphs. Now you can ask questions. Either in chat also, you can say. All of you are clear about these two concepts? My pace of delivery is okay? Clear? My pace of delivery is okay? Are you clear?
Yes, sir.
Right, okay. Shall I proceed further? The next concepts, shall I take it?
Yeah.
Right, okay. I'm taking the next concepts here. The next concept is the scales of measurement. This is also very, very important. Without understanding this, then again, we can't construct the graphs. The scales of measurement, probably some of you may aware about it. In the research methodology, we are learning about the scales of measurement. Any data when you are collecting it in your life, that may be classified under this four category: nominal, ordinal, interval, ratio. The nominal data is a one that it will help us to identify and classify. That's all. That is the purpose of the nominal data, is to identify and classify. Second is not only the identification and classification, the ordinal data will help us to either order it in ascending order or a descending order. The order is a matter here. Either ascending order or descending order is possible. But in nominal data, the sorting is not possible. Ascending order, descending order is not at all possible. When I am coming to the interval data, in the interval data, the two more properties, that is identification, classification, ordering is possible. And in addition to that, equal interval between the observations are there, but the origin of zero is arbitrary. The interval between the two observations are equal, but the origin of zero is arbitrary. Example, I can quote Fahrenheit. In centigrade, somewhere the 0 degree. In Fahrenheit, 0 degree somewhere. The 0 degree does not mean that nothing. Another example I can quote, zero size. Baby size is a zero size, we are calling it. Up a zero size, then again shirt or the clothes does not mean that nothing. That one of the size, then again we are mentioning it. Similarly, shoe size, then again index number. These are all the example I can quote it for interval data. The ratio data that it covers all the three properties: identification, classification, ordering, equal intervals, and in addition to that, real origin of zeros there. Zero means the real origin of zero. All metric measurements comes into that particular category of ratio data. The nominal data predominantly categorical variable. Ordinal data ranking variables, or that it can be ordered, but the intervals are not equal. Interval data, intervals are equal between two observations, but the origin of zeros are arbitrary. Then ratio data, that it contains all four properties. Identification, classification is possible by the ratio data. Ordering is possible. Equal intervals are there. Real origin of zeros there. So whenever you are seeing the data set, you should ask four questions. If four questions has been answered as a yes, that data set is a ratio data. If it's only the first three properties has been answered, the data set is a interval data. Suppose the first two characteristics has been fulfilled, the data is an ordinal data. The first only one characteristics that it has been fulfilled, it is called as a nominal data. Okay, and some of the examples here I am showcasing it here. Nominal data, employee ID. Even though the employee ID is a numeric number, you can't add, you can't subtract. Okay, so only that it has been used to denote the particular employee. Again, ordering is also not possible. The 24th employee is greater than the, then again the 20th employee. Like then again we can't say. Similarly, PAN number, student roll number, gender, car type, product model, any kind. Hereafter, what you have to do is whenever you are seeing a data set, you have to try to classify it in four categories, whether it belongs to nominal or an ordinal or interval or a ratio. Coming to the ordinal data, the example is rank. What the rank we are assigning it, age group, income group, year of study. These are all the examples. The year of study, again, say for example, one student has completed the program by 2022, another student has completed by 2023. But again, here we can order it. Earlier, later, like then again we can order it, we can compare. That is possibilities there. Coming to the interval data, as I stated previously, Fahrenheit Celsius is the best example for the interval data. Not only that, shirt size, shoe size, stock market index, Likert scale, rating scale, index number, all are example for the interval data. Especially in our social study research, the Likert scale, 5-point scale or 7-point scale is the best example for the interval data. Here you can then again fix it. Say for example here, highly satisfied to highly dissatisfied. Highly satisfied, satisfied, neutral, dissatisfied, highly dissatisfied. Like you can keep the rating scale. And for the rating scale, you can give the value like 1 for highly, 2 for highly satisfied, 1 for satisfied, 0 for neutral, dissatisfied for -1, highly dissatisfied for -2. That is also possible. Or otherwise, you can say that 5, 4, 3, 2, 1, respectively, highly satisfied, satisfied, neutral, dissatisfied, highly dissatisfied. Like that also possibilities are there. Depends on our choice. And coming to the ratio data, all metric measurements like a kilogram, height, weight, liter, okay, exam marks, sales, expenditure, all are example for a ratio data. But one thing, please understand, the ratio data can be converted into interval. Interval can be converted into ordinal. Ordinal can be converted into nominal, but vice versa is not at all possible. A nominal data never be converted into ratio data. That can't be converted into ratio data. Similarly, ordinal cannot be converted into interval. Interval cannot be converted into ratio. But vice versa is possible. Ratio can be converted into interval or an ordinal or a nominal. Okay, right. Now I'm asking one question. Please tell me. Then again, the number of tube lights in your room. What kind of a data you are generating through this question? Come on, please. Anyone can come forward. Number of tube lights in your hall. What kind of a data possibility? What is the possibility of the values? What possible values you can get it through that particular questions? I'm encouraging you to come forward. Whether it's right or wrong, based on understanding, you can say. With Nagamani, nominal, right? Okay. Suppose in my room there is no light at all. What the value you will record, madam?
0.
0. Yes. Whether the real that is the 0 is a real 0 or it's an arbitrarily you are saying.
Real 0.
Oh yeah. So the question, how many number of lights in your room generates ratio data? So what questions we are asking, what type of a data we are collecting, it's a matters here. Please understand. Okay, another example I am asking questions. Okay, please tell me how many children are there in your family? I am asking a question. Anybody? Yeah, real somebody.
Ratio data.
Ratio data, very good. Whether this data is a discrete variable or a continuous variable?
Discrete.
Discrete variable, because there does not have any value in between 1 and 2. Very good. Whether it is a measure or whether it is a dimension.
Measure.
Measure, right? Okay. Nagamani madam, superb. Such a kind of an insight, so always we should have it in our mind whenever we are seeing the data set. Otherwise, we can't think of what kind of a visualizations I can create, because this will make a huge impact on the type of the visualizations what you are trying to create. If it is a discrete variables, different kind of a, then again graphical presentation. If it is a nominal data, different kind. If it is a like different things. Let us see. I am including it in my then again presentations for each and every graph. What kind of a variables are required? Okay, right. Then again another questions I'm asking. Okay, in which city are you then again residing? I'm asking a question. What kind of a data you are generating? What kind of a data you are generating it?
Nominal.
Nominal, right? Okay, very good. Anybody else? Come on, come forward. Only Nagamani madam is saying. So, in which city are you residing? When I'm asking this question, it's only a nominal data because I can't order it. Chennai is then again Chennai is greater than the better than we can say, but it's a greater than then again Bangalore is greater than, like then again we can't say, right? So the city in which you are residing, that it will generate a nominal data. Okay, it's a common sense only. So you should ask 4 questions. Identification and classification is possible, ordering is possible, equal intervals are there, and finally it's a real origin of 0. If these 4 questions it has been answered, it is a ratio data. Only first 3 it's an interval, only first 2 it is an ordinal, it's the first only 1 it is a nominal data. And again you have to ask a question whether it is a discrete or a continuous, whether it is a measures or a dimensions. Like you have to keep on ask question so that you will get a more clarity about it. Right. Now let us move to the next level. Yes, all of you are clear about the concept?
Yes, sir.
Right, okay. Now I am taking it to the next level. It's absolute versus relative measure. Okay, with a small example, I am trying to answer or make you to understand this particular concepts. Let us take a known example here. Ram has secured 800 marks. Sita has secured 400 marks. Who has performed better? Why? Please come, anyone. Say your name and then again please give the answers and then again as well as the reason for that your answer. Come on.
I'll try to answer this, sir. Ram has secured 800 and Sita has secured 400, but we do not know out of how many marks they have secured.
Right, okay.
So,
suppose in this absence, please tell me who is a better.
It is an absolute variable. You cannot, there's no measuring.
Yeah, exactly. Madam, what she is saying is, then again, sir, if you are not saying out of how many marks, I can't answer this particular question. But probably whenever we are seeing such a kind of a numbers, always we will say that the ROM is better. Sita is not that much, because Ram has secured 800 marks, Sita has secured 400 marks. Okay, like we are trying to answer it. But when I'm saying that Ram has secured 800 marks out of 1200 marks, then again immediately you can say that Ram has secured only 66.67% of marks. But the Sita has secured 400 marks out of 500, that it amounts to 80% of the marks. Okay, now when I'm asking a question, now you will change your answer. When I'm asking this question alone without the out of marks, how many marks out of which they have secured 800, 400, you will say Ram is better. But when I'm saying, then again, out of 1200, Ram has secured 800, and out of 500, Sita has secured 400, then immediately you will change your answer. Sita is a better. Right now, tell me, the first one, 800, 400 is the absolute measure, and this 66.67% and the 80% is a relative measure. Which measure is a better measure? Now tell me.
Relative measure.
Relative measure is a better, right? Right. Now I'm taking you to the next scenario. Company A has earned 20% of return on investment. Company B has earned 200% of return on investment. Which company is a better company based on this information?
Company B.
Company B is a better company, right? Now I'm saying that the company A is nothing but is a ACC Cements. Their turnover is 2,000 crores. Okay. The company B is a mango shop person doing a business at Marina Beach, Chennai. Turnover is 1 lakh. Okay. Now tell me which company is a better company. Now tell me which company is a better company. Either A company is a better company or B company is a better company. In terms of a profit, the in terms of the volume of profit.
A is better.
B or A?
A.
A is a better company. Why? The company A earns 400 crores of profit. Company B earns a profit of 2 lakhs. In terms of a volume of profit, when we are talking about the company A is a better, right? In the scenario 1, we concluded that the relative measure is a better measure. But here, again, the relative measure does not give a proper answer for us. So now, what is thing is here, my dear friends, please understand, whenever you are trying to then again interpret the data, always you should keep both the values, absolute measures and the relative measures together. So in isolations, you should not then again give any answer for that one. Suppose if you are having only absolute measure, don't comment anything. Please ask for a relative measure. In association with the relative measure, the absolute measure has to be interpreted, or the relative measure has to be interpreted in association with an absolute measure. Now, are you clear about the concept absolute measure and the relative measure? Yes?
Yes,
Yes?
sir.
Right. Why I'm saying is, whenever we are constructing a graph, then again, if we are taking a combo charts, then again in one axis we can take an absolute figure, in another axis we can take an then again relative figure. Both we can bring it together and we can showcase. Or otherwise, two separate graphs we can use it for. One is for an absolute figure and another one is for an relative figure. I hope all of you can understand. Right. So far, the last half an hour, what we have covered is a concepts called as, once again, I'm revising it quickly. Then again, we started with the dimensions versus measure. Dimensions is a qualitative data, and that it can be sorted. And the measures is a numeric variable or a numbers that it can be sorted. Okay. And also, we may say that the dimension is a independent variable, then again measures is a dependent variable. Discrete versus continuous examples we have seen. The discrete is denoted by the blue color in tableau, and the continuous variable has been denoted by the green color. Both are having a huge impact on the visualization. and the x-axis in which then again discrete variable will be accommodated, in y-axis the continuous variable will be accommodated, and the continuous variable cannot be sorted, and then again the discrete variable can be sorted. This is a example I have shown to you how the discrete month will look like, how the continuous month will look like. Okay, right. Now, next level, what I have taken it is a scales of measurement in which I have covered nominal data, ordinal data, interval data, ratio data. Okay, and there are 4 properties we have covered. Identification and classification is a one property. Ordering is another property. Equal intervals and between the observations are third property, and real origin of zero is a 4th property. All the 4 properties exist. It's called as a ratio data. Only 3 interval data, only first 2 ordinal data, only the first character, then it's nominal data. So that is have a huge impact on the visualization process. Okay, the examples I have shown here. Hereafter, whenever you are asking a question, you should cross-check whether my question generates a nominal data, ordinal data, interval data, ratio data. Like you have to cross-check. Okay, and which is the most preferable? Ratio data is the most preferable. Which is the least preferable? Nominal data is the least preferable. Why? Because the ratio data can be converted into nominal, but the nominal can't be converted into ratio. Similarly, for ordinal and ratio, interval and ratio. Ordinal cannot be converted into ratio, but ratio can be converted into ordinal. Similarly, interval and ratio. Okay, so always prefer to collect the ratio data. Wherever it is necessary, we may convert it into interval or an ordinal or a nominal. Coming to the next one, absolute measures, relative measures. With a small example, I narrated what do you mean by absolute measure, what do you mean by relative measure. In the first scenario, we concluded that the relative measure is the best measure, but by covering the second scenario, we have concluded that not only the relative measures, absolute measures are also to be considered while we are interpreting data or while we are reading the data. In isolations, that it will mislead us. So always please consider both absolute measure as well as a relative measure. Right. All of you are clear about the concepts? Whatever I have covered is already we learned only. Just I have recapped everything in a structured way. And now we can jump into the different kind of a graphical presentations. I'm using Excel and Tableau also. I will load the data and I will demonstrate to you how can we construct the graphs. Here my emphasis on what kind of variables we are using it for each and every graph and how to interpret the data. Okay. Now I'm opening up the session for question and answers. Just in another 1 minute, I will wait it for your questions. And any doubts or any clarifications so far on the concepts, you can ask now and clarify the doubts. Thereafter, I will move to the next topic, pie chart and pi of pie chart. That is a basic chart. Any doubts? Even you can type it in the message. I'm opening the message and I'm seeing the message only. And even if you are not opening up the microphone, then again you can type it and you can send the questions. Or otherwise you can switch on the microphone and then again you can ask question. I will clarify your doubts. Any type of a doubts, don't hesitate. It's only a learning session. So I'm sharing my knowledge. That's all. Okay. All of you are here. All learned people we are here. Only just I'm sharing it, the knowledge of what I have gained already. That's all. Any questions? I would like to make it more interactive session.
Sir, may I?
Madam, Nagamani madam, tell me madam.
Sir, actually you said the next topic would be on MS Excel and Tableau.
Yeah.
So like Excel is all like we have with us like MS Office and we have MS Excel. And how about Tableau, sir? Like what is the source of getting a Tableau?
Tableau, madam, there is a version called as a public Tableau. You can download it from the Tableau website. It's a free. The learners can download and install all kind of features. We can use it. There is no restriction at all. But only the thing is, you can't save the files in your hard disk, that it will be saved in the cloud platform. So sensitive data, you can't use it. You have to create your own account, and you have to open the account in Tableau. Thereafter, you can download the software file, public, Tableau public. Please type in the Google Tableau public download, free download. You can download the latest version, you can install it, and you can start to learn. Okay?
Thank you, sir.
Right, okay. Whatever you are learning it in Excel, the same thing is applicable in Tableau also. But only the thing is ease. The Excel little bit we have to work, but in Tableau, then again, just like that, then again we can generate the n number of visualizations. The Tableau is a edge over the Excel, but Excel is everywhere. That is why then again I am covering the Excel also. Right? Right. Any other questions? Right. Shall we start with this? Right. Okay. I'm taking you to the next one. Here is a pie chart. Here, as far as this is one example of a pie chart. Whenever I am showcasing the pie chart, I'm in the top, I'm showcasing variables required. Suppose if you'd like to construct a pie chart, one dimension with multiple levels is required. One measure is required. Now, if you are asking a question, sir, if I'm having a more than one dimension, pie chart is not appropriate. Sir, I'm having a more than one measure, pie chart is not appropriate. One measure with the one dimension, that too the dimension should have a multiple levels. Okay, then you can construct a pie chart. This is a rule of thumb. Here, I'm showcasing the pie chart, shows the sales across various regions. So here the colors are there. The different colors has been denoted by the legends. Okay, and central, east, south, and west. Okay, the green color is an east. So 6,78,071 is a sales value. So the entire pie chart has been shown here. Right. This is a pie chart. I'm now taking you to the Excel file. Now this is an Excel file. This is the raw data. This data set is a sample superstore data set that is predominantly available in net for practice purpose. Even you can download it, sample superstore data set. Even if we are downloading Tableau, in Tableau also, then again they are using this sample data set for demonstration purpose. It's easy to understand. Now I'm trying to introduce the data set. It's an order details. And how many orders are there? See here, nearly the records, nearly 9,994 records are there. Okay, right. So that it contains order number, order date, ship mode, customer ID, customer name, segment, country, city, state, region. See here, state, postal code, region, product ID, category of the product. Like that keep on goes, subcategory, product name. But again, the last one, sales, quantity, discount, profit. Now just I'm asking one question. Let us take the subcategory. Can you now tell me by the learning of the concepts, whether it is a dimension or whether it is a measure, whether it is a discrete or whether it is a continuous, whether it is a nominal data or an ordinal data or an interval data or a ratio data? Subcategory. Let us take. Come on, anyone, please. Right or wrong, don't bother about it. Even if it is a mistake, then again we may correct it.
It's dimension data.
Dimension, very good. Dimension data. It's a dimension data. Whether it is a nominal, ordinal, or interval.
Nominal data.
Nominal data, very good. Then again, whether it is a discrete or a continuous.
It is discrete data.
Discrete data, very good. That's all. Such a way, whenever you are having a data set, you should start to interpret. Okay, right. Now I am asking a question. Sales. Now the sales. Anyone other than last, madam? Madam, what is your name?
Sir, myself, sir, Nagamani, sir.
Oh, Nagamadi madam has answered it. Right. Okay. Anyone can come forward. Sales is very easy to understand, and then again say about the the nature of the variable. Come on, anyone? Why I'm insisting is, sir, constructing the graph is the system will do. Whatever you are dragging and dropping, then again system will do everything. But understanding the variable, bringing the appropriate variable, bringing the variable into the appropriate structure that it matters to construct the graphs. That is why I'm giving an emphasis. I hope all of you can understand. Anyone can come forward quickly. So sales. What is a, whether it is a measures or a dimension?
So it's a measure.
It is a measure. Very good, madam. Then
Then
whether it is a continuous or it's a discrete.
it's continuous.
Continuous variable. Very good. And again, whether it is a nominal or ordinal or interval or a ratio.
So it's an interval.
Now, are you saying
ratio.
that the origin of 0 is an arbitrary 0? Suppose an order that does not contain any value. Suppose it is a free gift. The order number will be generated. At the time, what is the sales value you will mention?
It's ratio scale.
It is a ratio scale. It is a ratio scale because the order may have a value of a 0, that is not at all an arbitrary, right? So similarly, please try to interpret the data. Interpret the data variable. That is very, very important, right? Now it's a huge volume of data. Again, if I'm filtering the region, I can see 4 regions: central, east, south, west. But can I use this raw data to construct a pie chart as such? It's not possible. So what I have to do is, in order to construct a pie chart, see, I'm going to the next page. I'm increasing the size also. I'm reducing my ribbon also. I'm collapsing the ribbon also. See here, this is a pie chart. What I have shown it in the presentation. In the side, please see here, this is the summary. This is a aggregated data. This is a summarized data. What I have to do it, I have to sum up all the sales pertaining to central. I'm supposed to sum up all the sales pertaining to east, south, and west. So this particular summary data has been used to construct a pie chart. Now you can ask a question, sir, how can we summarize the data? Summarizing the data in number of ways we can do with the functions, simple function sum, or alternatively we can go ahead with the pivot table. I use the pivot table concepts. I use the pivot table and I have summarized everything. I hope all of you may aware about it. For an example, then again I will showcase to you. See here, I can put a cursor here. Control plus A will help me to choose the entire data range. In the insert menu, in the left hand side, when you are seeing it, there is a concept called as a pivot table. Pivot means rotate. A table that is rotatable in nature is called as a pivot table. When I'm clicking from table range, this is a range what I selected. If I'm clicking it, the dialog box opens and that is ask me whether the new pivot table has to be shown in new worksheet or existing worksheet. I'm leaving the radio button as such, the new worksheet. I'm clicking OK. See, the pivot table is now ready. I'm increasing the size. Now you can see. See, this is a pivot table in the left hand side. In the right hand side, when you are seeing it, it's a pivot table fields. All the variables in the source data is appearing here. See here, row ID, order date, ship mode, customer name, segment, country, region. All the variables are here. Here in the bottom, please see here, there are 4 quadrangles: filter, column, rows, values. See here in the rows, if I'm taking the region just in a drag mode, if I'm dragging and dropping, all the regions will appear here. See here, the summarization is how easy. Please see here. Now I'm taking the sales and I'm putting it in the value area. Please see here, now the count of sales. It is not a count of sales. In the right click context menu, I'm changing it as a sum of sales. See here, the sum of sales is ready. With the sum of sales, see here in the sum of sales, what can I do is I can choose this pivot table. I can go to insert menu and I can take the chart named as pie chart and clicking OK. See here, the pie chart is ready. The rest of the things what I did is a cosmetic values, appropriately making the outer lines looking fine, color changing, then again font size, rest of the things are all then again aesthetic values. And when I'm clicking this table, I can add labels also, and all features. I hope all of you may aware about it. But the crux here is whenever there is a raw data, such a kind of a raw data, huge volume of data, first we have to summarize. What I would like to do is I'm picking up one dimension. What is a dimension here? I'm taking it. Region is a dimension. I'm taking it. What is a measure? I'm taking it. Sales is a measure. I'm taking it. For constructing a pivot table, what is required is one dimension with multiple levels. What is a dimension? Region. How many levels are there? 4 levels are there. And what is a measure? Sales. With these two variables, I constructed a pie chart. Now I am coming back to the meet. Now I am waiting for your reply or questions. Are you clear about it? When can we? Then again, so again, it's a choice. Now you can ask one more question, sir. With the one dimension and one measures, can I construct a bar chart? Yes, we can construct a bar chart also. But again, choice is ours. But whenever you are having a 2 dimensions with the 2 measures, you can't prefer the pie chart. So for picking the pie chart, what is required? You should administer only one dimension with the multiple levels and measures. That's all. One measure. That's all. Are you clear? Now, because normally we are trying to construct a pie chart. We are selecting a data. We are trying to, sometimes that may come, sometimes that may not come. We are struggling here and there. But with that knowledge, yes, I should have a one dimension with the multiple levels. I should have a one measures to construct a pie chart. So the summarization process, what the tool I used it? I used the pivot table. Either you can use the other functions also. Some of the functions, filtering and adding some, but all are laborious. But the pivot table construction is too handy. You can also learn. Suppose if you are not having that much of a knowledge, say n number of materials or n number of videos, n number of resources are available in the net pivot table, you can learn. Just to select a range, go to insert menu. In the left extreme, you can click it, pivot table. Pivot table will be loaded. And it's a self-explanatory, it's a common sense. There is no programming language, there is no kind of then again difficult technical concepts. There is no technical concepts, only the logic, that's all. Right. With this, I'm waiting for your question. All of you are comfortable with the pie chart? Yes? The data structure here, please see here in the rows, I am keeping the dimensions. And in the value area, the table value area, whenever there is a table, 3 major components. One is the rows, another one is the columns, another one is the body of the table. Okay. Here I am using the rows and the body of the table. Okay. Right. Comfortable?
Yes.
Shall I proceed further?
Yes.
Yes, sir.
Right. Okay. Now I am taking you to the next level. Okay. It's a pie of pie chart. The pie of pie chart example here I'm showcasing here, and I'm coming to the first presentation, and thereafter we can go in the presentations. Please see here, what are the variables required? 2 dimensions with the multiple levels. Sir, just now you stated that only one dimension is, yes, the only one dimension is permissible for the pie chart, but a pie of pie chart you may permit it to use a 2 dimensions with the multiple levels. One dimension for a main pie and another dimension for a pie of pie. And one measure is required. The same measure is required. Suppose sales means sales, profit means profit, or otherwise even you can use the two measure also. Suppose the pi of pi, then again you can sub-classify with the different values. But again, it's a more sensible thing as only one measure. Now, if you are seeing the graphical presentations, the pie chart, the main pie chart, that is a left-hand side pie chart. Okay, green color, blue color, dark green, and then again another color that it shows the then again region-wise sales. Now I'm keen on west. In the west region, what about the then again what about that particular then again sales across segments? There are three segments are there: consumer segment, corporate segment, office segment. So now this is 7,25,458 has been sub-classified or bifurcated, not bifurcated, or then again regrouped as West corporate, how much sales, West consumer, how much sales, West home office, how much sales. When you are adding these three values, 2,25,855, 1,36,722, and 3,62,081. If you are adding all these, that it's amounts to 7,25,458. Are you comfortable now? Are you clear of the pie of pie chart? If you are clear, then again I will take you to the data structure. What kind of a data structures will help me to construct such a kind of a pie chart? So okay, clear now?
Yes, sir.
Right, okay. Now I am taking you to the Excel sheet. In the Excel sheet, please see here, this is the same pivot table. I will showcase the same one. Here I am deleting it here. I'm keeping in the rows, it's a region. Okay. And what I'm trying to do is I'm taking the category, product category, segment. It is not a category, it is a segment. There are three segments already we have seen. I'm dragging and I'm putting it below the region. See here how I'm preparing the table: central, consumer, corporate, home office. Like I'm creating a summarization table. This is a two-layer table. Normally we will call it as a two-layer, three-layer, like then again we will say this is a second level of the row variable. The central has been bifurcated into three: consumer segment, corporate segment, home segment. This button will help me to collapse. I'm collapsing everything and I'm keeping the West alone. So such a way I have to structure the data. After structuring the data, I have to go to insert. Then from the chart, I have to take pie of pie chart. If I'm taking the pie of pie chart, the pie of pie chart will be created. 4 regions will be there, and then again further I have to do it. Okay. And here I can make it changes. I can make a changes. Okay. So when I'm double clicking it, so I can take it and then again I can subclassify also. Okay. I can subclassify also. So this is a way I have to construct the pie of pie chart. See, this is a pie of pie chart I constructed. The data structure is supposed to be in the rows. I have to keep the region, and the region has to be subclassified as West. Here, the only one part of it I am subclassifying. Suppose if you are interested in South, then again you have to subclassify the South. You can open up the South, and then again I have to close it so that then again the South will be subclassified here. Please see here, the South will be subclassified and the rest of the things will be shown like this. So like what you can do is you can do the pie of pie chart. The customization is required. Each and every component of the graphs can be picked up and that it can be customized. So for example, this particular slicer, when I would like to customize, choose it, double click it, that it will open the data point here. Whatever you would like to do it with the series options or a fill options, or it's a kind of anything, then again you can do. See in the right hand side, format data point. Like see here, if it is a data labels, just to select it and double click it, format data label will come. Like each and every object you can choose it and then again you can customize it. Okay, are you clear now? Comfortable? Clear? What is the data structure is required? The data structure is in the row. The first level is a region. The second level is a segment. The segment will be the pie of pie chart. Okay. Anything, then again you can bring it like such a kind of a variables, and then again you can construct a pie of pie chart. Okay. Right. Now it's a time to take you to the Tableau. So in the Tableau, just I will keep a demonstration because I can't save the file. I can save it in the cloud. Now I hope all of you can see. I'm clicking the Tableau software that it's loaded. Now that will be loaded. I have shared the entire window of my computer. So the loaded window will be visible. After cross checking, I will take you to the next level. Sir, the data set, you can download it as sample superstore data. Everywhere is available in Excel, .csv file or Excel. Sample superstore data. Type it in Excel, type it in a Google, and if you are clicking it, this set of data you can download from the website. Similarly, Adventures works. That is a Microsoft sample data set. Predominantly, that has been used for Power BI. Like any data set, you can choose its sample data set and you can start to learn. Or not necessarily, we can have our own data set and we can use it for practice purpose. Any other questions? Shall I take you to the next level? Yes?
Also type the name of the source where we can download the Tableau.
Not necessary. Tableau, oh, Tableau you are saying. Tableau, then again, just you can type it Tableau public free download. It's open to public so that you can download it. So for example, what is the configuration? For Windows 10, 64-bit is required, or Windows 10, 32-bit is required, like you have to choose it. See here, can you see my window? Madam, can you see my window?
Yes.
And what is the search I used it? Tableau public free download for Windows 10, 64-bit. Suppose if your system is a 64-bit, download it, or otherwise it's a 32-bit, you have to download 32. See here, if I'm clicking download a Tableau desktop or Tableau public, here Tableau public is there. Please see here, the second one is a Tableau public. Tableau desktop is a 14 days trial, but a Tableau public is every time. First time that it's ask you to, then again ask you to register. First register it and then again download the public. Okay, madam?
Okay, sir. Thank you.
Right. Now, can you see my window? This is a Tableau welcome window. Can you see? In the Tableau, the left-hand side, what is the left-hand side? What is the major? Then again, the word. I'm circling with my mouse pointer. What is the word? Can you see? Can you see? Connect. Yeah, this is a connect. This will help me to connect from any source. Either I can connect with the PDF document, Microsoft Excel Access, then JavaScript file, text file, statistical spatial file, even SPSS, you can get the data. You can take the data to Tableau. So Microsoft Excel, here I'm clicking Microsoft Excel. Here, this is already what the files I opened. This is open is a one. Okay. And I'm clicking Microsoft Excel. That system asks where the file is. I'm locating my file location. My file location here is Tableau working file, in which I'm keeping the sample superstore data. See here, sample superstore data, I'm keeping it here. Why I'm using this particular data set is when you are going back and when you are searching it in the net, same kind of a data set is available, very easy for you to synchronize what you learn and what you are trying to read also. This is another window. I'm not now teaching that particular Tableau here, but again, this is I have connected that particular Excel file. Can you see this window? This window is totally different. And this is actually the starting window. See here, this is a starting window. And this is a window in which we landed after loading the data. Now I have get connected. The data is get connected. There are three sheets are there: order, people, return. Order, just I'm dragging and I'm dropping it here. If I'm dragging and drop it here, the orders data will be loaded. What I have shown in the Excel sheet, order ID. Okay, see here, can you see the thing? I will showcase to you. See here, order ID, order date, ship mode, then again customer name, segment, country. Same data set I have loaded into what, my dear friends? Tableau. Tableau here, this is a loading window. This is the first one is a welcoming window. The second, this is a loading window. The data has been loaded. This is a connection window. And this is a loading window. Now, similar to Excel, there are n number of sheets I can create. See here, this is a sheets. If I'm seeing the sheet, see here, in the left-hand side, these are all the first group is the dimension. The second group is the below the discount. I can't increase the size, but then again try to then again zoom it in your Google Meet, and then again see left hand side, all variables are there. Whatever the variables we have seen, order ID, region, segment, sales, everything is there, right? Now I'm taking this region into the column. This is a column. I'm taking the sales into the rows. When I'm taking it, immediately the system throws bar chart. Again, I can change it. Show me. In that, I can click it the pie chart. The pie chart I can showcase. Then again, I can increase the size also. See here, entire view. I can add the labels. I can add the region also in the label. I can add the sales also as a label. See here, can you see the thing? So beautifully, I can draw the pie chart. But what is required is the clarity. What is required? What is required? One dimension is required with multiple levels. One measure is required. Like that knowledge is required for constructing the pie chart. Okay. See, one observations you can see. In Excel, what I stated is the raw data should be aggregated or summarized either by manually or either by pivot table. Thereafter, you have to construct a charts. But in Tableau, there is no such a kind of a aggregation process or a tabulation process, summarization process. The system will do on its own in the background instantly that it will throw the visuals. Okay, but one thing you have to understand, what type of a variables is required. That is a matter here. I will showcase to you in the Tableau also how when I am converting the variable into discrete or discrete to then again continuous, how the graph will look like, how the insights are getting changed. That it will I will showcase to you. Okay, clear? In Tableau also I have shown. First, what I have stated is I established the connection with an Excel file. I loaded into the order sheet into the Tableau. After loading it, I took the region and then again sales. Instantly, the system throws a bar chart, but I tried to convert subsequently into pie chart. That's all. Any doubts or any clarity is required? Shall we move further? Proceed. I'm waiting for your response. Speed is okay?
Yes, sir.
Right, okay. Now I'm taking you to the next one. The next one is a bar chart. This is a simple bar chart. Bar chart have a different types. Simple bar chart. This is a simple bar chart. I'm taking the same region and sales. What I used it for the pie chart. This is a different kind of a visualization. Second, this is a cluster bar chart. Okay, the cluster bar chart, in that I took it segment and sales wise. Pie chart, what I created the same way here. So the sales is a measures, segment is a, then again it's another dimension, one dimension, region is another dimension. When you are seeing in the simple bar chart, see one dimension with multiple levels. This dimension always into x-axis. The measures always into y-axis. Already I have shown to you, is it right? The discrete will come into x-axis, the continuous variable comes into y-axis. Similarly, the dimensions predominantly will comes into x-axis, the measures will come into y-axis. Okay, right. So in that, only one dimension and one measures will help me to construct a simple bar chart. When I'm adding a one more dimension, what is a one more dimension here? I'm adding a segment. When I'm adding a segment, then you can see here the graphical presentation look like this. The region, the first dimension into the x-axis, in the y-axis, sales value, and the segment is in the series. The blue color indicates consumer, red color indicates corporate, green color indicates home office. That has been denoted by the legends. Can you see the legends in the bottom of the graph? Now, you are comfortable with how many variables are there, what type of variables required, how many variables are required for a simple bar chart, which one will come to the x-axis, which one will come to the y-axis. Similarly, for a cluster bar chart, how many variables are required, which one will come to x-axis, which one will come to y-axis, which one will come to the series. I have shown to you. What is a data structure? Next question. Because in Excel, when we are trying to construct a bar chart, then again, I'm taking you to the next level. This is a bar chart, simple bar chart. See here, same way in the pivot table, I have consolidated the data. I have summarized the data. Using this summarized data, see here, I will showcase to you. See here, I will showcase to you in the pivot table. For understanding purpose, I am constructing a pivot table for you. See here, and I'm taking insert, graph, simple bar chart. See here, the simple bar chart is there. That's all. It's very simple, very easy. Once if you are having a more clarity about the types of variables, how to keep the variables, where to keep the variables. See, in the rows, I'm keeping it here. If I'm keeping it in the columns, totally it's a different scenario. When I'm keeping the segment into the column, see here, the data is further subclassified or sliced. Each and every region has been sliced by the segment, consumer segment, corporate segment, home office segment. So in the column, I'm keeping segment. In the row, I'm keeping region. In the body of the table, I'm keeping the value. Now, if I'm clicking the insert menu, if I'm choosing a bar chart, need not necessary to say cluster bar chart. Even simply if you are choosing a bar chart, the bar chart will be created as a cluster bar chart only. See here what happens. The x-axis region is occupied. Y-axis sales value has been occupied. The segment becomes a series. In the series, blue color, red color, green color. See, now the learning here is, my dear friend, the row variable becomes x-axis. The body of the table will become y-axis. The column variable will become series. So in this structure only, you have to feed the data to construct a graph in Excel. That is very, very, you should have a clarity. And because in a day-to-day life, you will normally have a raw data, huge volume of data, 10 lakhs rows, 20 lakhs rows, like there again, you will have it. After summarization, only there again I can construct a bar chart. Otherwise, it is not at all possible. Please see here, if I am taking the segment, or say, for example, if I am taking a segment or region, see 1 minute, I'm taking the region, I'm taking the sales value, I'm copying it, I'm putting it in a one Excel sheet. Please see here, I'm putting it in a one Excel sheet. I'm trying to construct a chart. Please, I will showcase to you. I will construct a chart. How the charts looks like. Please see here. Does not make any sense. Normally, we are trying to construct the charts like this. And we are saying that, yes, I can capable of taking the output of the charts. But whether this particular chart is appropriate? No. It is a bar chart, but does not communicate any meaning. Each and every data point is considered as one of that one into the x-axis. Okay, are you clear now? So even if we are extending that one chart, the chart will be any size because the total number of records is 9,998 records. So 9,998 data points in x-axis will be created. That is a meaningful graph? No, this is not the way of creating a graph. Actually, my dear friend, in Excel, what you have to do is you have to summarize the data. See here, I summarized the data here. I'm increasing the size. See, I'm talking about from the raw data, how to construct a table. Okay. So once if it has been summarized, from the summary, we can construct the beautiful cluster bar chart. For the cluster bar chart, how many variables are required? 2 dimensions, 1 measure. 1 dimension in x-axis, 1 dimension into the series, 1 measure into the y-axis. That clarity we should have it in our mind. Then only we will start to think of before constructing a charts. How many variables are there? Which variable will goes where? Like when I'm trying to visualize, then only I can say that, oh, I can keep this particular variable into x-axis. I will keep this variable into series. I will keep this variable into y-axis. Like I can think of it and I can bring it. Constructing a chart is not at all a matter, but how you are summarizing the value, how you are keeping the value, and how many variables are there, and what type of charts you are picking up. It's a matter here. Say, for example, here I can say, I'm choosing the summarization data. It's a summarized data. I'm trying to construct a histogram. See, when I'm clicking histogram, the system shows this data structure with which you can't construct a histogram. For a histogram, the variable requirement is totally different. I can't think about the histogram for this given data variables. First, we have to understand. Okay? Clear about it? I hope how important understanding the variables, types of variable, what we have seen it as a dimension measures, discrete continuous, then again, nominal ordinal interval ratio data. Okay? Clear now? Is there no? Shall I move further?
Yes, sir.
Something if you are saying, then only then again I can
Yes,
move
sir.
forward. Okay, only few people we are here, only small group, it's an advantage. Okay, you can feel free and you can interact. Don't hesitate. Whatever may be the doubts you can ask. So one thing we should be very clear. If we are understanding this data type, that is a variables type, then again the classifications, all these things that it in a great way help us. Otherwise, whatever may be the software, we can't construct any graphs. Thereafter, so only the sky is the limit. Our innovative thought process, our thinking process is the limits. Okay, for constructing the charts, different charts, different varieties we can construct it. But the understanding here is what kind of an inputs I'm giving it. That is very important. Okay, right now I'm taking you to the next level. The next level of the chart is a stacked bar chart. What do you mean by stacked? Stacking. What is the meaning of stacking? Anyone can come forward? What is the meaning of stacking? Meaning of stacking? Or can you give an example of stacking? Please come on. I'm waiting for your response. What do you mean by stacking? Stack the bags, like we may say. If
Segmentation, sir. Different segmentation we have.
not segmentation, actually.
One over the
Stacking.
other. One
Yeah.
over the other.
One over the other. Aparna madam says, very good madam, one over the another. Okay, is called as a stacking. Okay, right. So the same meaning here we are applying. Now we are bringing a different kind of a visualization. This is an example of a stacked bar chart. I'm taking the same variable. Why I'm taking the same variable is in order to make you to compare and contrast the different charts. The same variable here, I'm taking the region and I'm taking the segment, I'm taking the sales value. So now how many variables are there? 2-dimension variables with multiple levels and one measure. As usual, the one measure in y-axis, the 1-dimension region into the x-axis, and in the series, the second dimension. Okay. What is the second dimension here? Segment. The segment here as shown here. Please see here, the home is the orange color, violet color is a corporate, consumer is a, then again, it's a pink color, I can say. So one after another, a segment over another segment, a segment over another segment. So here, consumer segment, above which corporate segment, above which home office. I'm showcasing here, and this will give a different kind of a visualization for you. So the before visualization is different, and this visualization is different. The variables are similar, the measures are similar, everything is similar, but the way in which we are visualizing the data is totally different. Okay, and how to interpret it? Here, see here, I can compare to here across the day. Each and every graph it's have its own unique strength and weakness, my dear friends. Please see here, here also the same thing here. Okay, this is called as a stacked bar chart. As an extension of this, I'm taking you to the next level called as 100% stacked bar chart. What do you mean by 100%? Again, I'm taking the concept called as an absolute measure, relative measure. The previous one is an absolute measure, and the next one, 100% stacked bar chart, is a relative measure. Each and every region sales value will be assumed as an 100%. So, for example, here, let us take central. Can anyone can say that what is the central value here? So too small to visualize. I'm reading it on behalf of you. 2,52,031, 1,57,996, 91,213. I would like to take up some of these values here. The sum of the value I have to take it up. The sum of the value I have to assume it as a 100%. I'm taking you to the Excel sheet so that it's a very clear of what do you mean by how to calculate stacking of bar chart. See here, what is the total value here? I'm increasing the size now. What is the total value here? 11,61,411. Here I'm showcasing calculation equal to what is the central value? 2,52,331 is the central value, divided by what is the total value? 11,61,401. I'm dividing this value. That it will give a percentage, 21.700%. Like that it will. This is called as a column percentage. And what is a row percentage? Here I'm not supposed to take the column percentage because it's a consumer. I'm supposed to take the central. Because the central I am supposed to take it as 100%. What is the total? 5,01,240. Here see, I am calculating it equal to 2,52,031 rupee of consumer of the total sales value of the central. How much is the total sales value of the central? 5,01,240. Okay, if I'm dividing it, 50.28. See here, I have calculated here. In the pivot table, there is a one option called as, see here, show value as. Here, this is the exact value. If I'm taking the show value as a row percentage, the row percentage will be calculated for me. This summarized data with which I can construct a 100% stacked bar chart. This is called as a 100% stacked bar chart. Okay, 100% stacked bar chart. Okay, percentage of segment sales across region. Each and every segment, how much percentage of each and every segment sales happen. In the central, the majority of the segment sales goes to, then again, what is the blue color? Home office. Next to home office, which segment that it goes? Corporate. and then again the blue color is a consumer, and then again the green color is a corporate, and the another one is a home office. So in the central, the majority, even in the across the 4 region, the major segment is a consumer segment. The next segment is a corporate, and the least segment is a home office. From this percentage, easily you can say that which segment predominate or dominates across the region, we can say. Here, this stacked bar chart, it's an absolute figure. The absolute figure does not give the result, or absolute figure does not give the clue, which even in this, based on the size, we can say, but this 100% stacked bar chart clearly says the consumer segment of predominantly occupies in all region. Next to that, corporate region. Next to that, home office. And you can compare this absolute figure as well as a relative figure. Relative figure purpose is totally different, and absolute figure purpose is totally different, because both the measures are very, very important with the scenario we have learned. Now I am waiting for your response. Are you clear about it? How many variables are required? 3 variables. How many dimensions? 2 dimensions. One is in x-axis, another one is in series. How many measures are required? 1 measure is required. That is supposed to be in y-axis. This will give a clarity of constructing the graphs. Right. Now I am waiting for your questions to clarify your doubts. Let us see it in the Tableau. Right now I am taking you to the Tableau. Already we loaded and we have constructed it. The same one we can take it. Region, I am taking it into the rows. See here. I am taking the sales. I am putting it in the column. See here, bar chart is ready. Now I am increasing the size. See here, increasing the size. I am adding the labels. I am adding the labels. I am adding the colors of each region. Yes, I am adding the colors of each region. These are all the cosmetic values. Adding a value, colors, then again appearance, font size, all are all cosmetics. Okay? Right. This is a simple bar chart. The same simple bar chart in which I'm adding a segment. See here, next to region, I'm adding a segment. Please see what happens. See here, this is a clustered bar chart. This is a clustered bar chart. Okay? The cluster bar chart, again, I'm taking the values and I'm editing the x-axis. I can convert it into 100% stacked bar chart. Okay? Right. I'm not going in detail about it, but Tableau is more versatile. Just drag and drop. But only the thing was which variable, where to drop, how to drop, and then again, what kind of a changes I'm supposed to make it to take the meaningful results. That is very, very important. In Excel, with the raw data, you can make a lot of mistakes. But here in Tableau, there is no scope. But again, in Excel, if you are comfortable with the pivot, pivot will help you to consolidate the data, aggregate the data. With the aggregated data, summarize the data, you can construct the graphs. Okay? Right. Now, as I planned, last 2 minutes in which I'm trying to showcase the other graphs, that is called as a line chart. The line chart predominantly used when we are using the time duration. For the line chart, the variables requires 2 dimensions with multiple levels is required. 1 dimension in the x-axis, another dimension in the series. X-axis is a dimension, preferably time or duration or a period. And another one is a measure, predominantly that is in y-axis. Here, the same combination I took it. Okay, segment. But here in the x-axis, I'm taking the time dimension. Order date, I took it. Order date into the x-axis and the sales into the y-axis, the segment into the series. Okay, right. the order date has been grouped as, see here, grouped as year and quarter. 2014 quarter 1, quarter 2, quarter 3, quarter 4. Like that it has been grouped here. Okay. I'm taking you to the Excel, the structure of data, to showcase you to the structure of data in the line chart. Please see here how I have constructed it. See here, the order date, I took it and I grouped it as 2014-15. Because when I'm taking the order date, the individual order date will combine. I have to group it into year and quarter. Even I can take it the level month also possible. Possibility is there. But here I'm taking to the two level of grouping year and quarter. Even you can slice the data up to the level of a month or week, any kind of a date hierarchy with which then again you can slice and dice the data. In the column, I took the segment, and in the body of the table, I took the sales value. I put it here, I got the results like this. This is a line chart. The same line chart, I can do it in Tableau. I can take the order date. If I'm putting it in the order date in the rows, please see here, add all the members. Yes, I can take it as all, sorry, order ID here. I have to take the order date into the rows. Please see here, the rows not similar to Excel we can construct. I'm putting it in the column. What will happen is the grouping will be done automatically. The highest level of grouping is in year. And when I'm clicking the plus sign, that will be subclassified by quarter. That again subclassified by month. So at any point in time, I can have the levels. Here I'm keeping the two levels and I'm taking the sales and I'm putting it in the rows. Please see here, the chart look like this. What is the problem here? The problem here is the year. What is the color? Blue color. The blue color indicates what, my dear friend? Discrete. Green color indicates continuous. That is why then again I stated that the discrete and continuous variable have its own impact. Now when I'm changing this variable as a, see here, continuous variable, please see here, I'm making it as a continuous variable. I make it as a continuous variable. See here that it becomes a green color. Please see the charts look like this. And I'm taking the segment and I'm putting it in the color. See here, the same diagram, what I generated in the Excel, I'm getting it here. I'm getting it here. See here, 14-15 level. Okay, are you clear now? So, what I have shown previously, system by default take it the order date as a discrete variable. But when I am converting into continuous variable, the visualization is totally different. See, once again, I'm dropping it. I'm taking the order date. Please see here, system will take by default what the variable type discrete. The discrete is totally different. If I'm making the levels, again, it is a different. When I'm converting this into continuous variable, please see here, continuous variable, totally it's a different structure. The way that it has been constructed is totally different. When I'm taking the next level, it's a quarterly data. When I'm taking it as a monthly data, it's a monthly data. When it is a daily data, weekly data, daily data, any levels, just like that, then again I can move, go back and then again come back, and then again I can generate the data. So now you may ask a question, sir, whenever there is a date, whether we have to convert it into continuous? No. What is the purpose? Purpose with which we have to decide whether that's supposed to be a discrete variable or a continuous variable. Further in detail, then again, we can discuss tomorrow. And whenever you are using a line chart, obviously, you should take the time as a continuous variable. But when you would like to construct a chart, the chart, then again, what I can say is a discrete variable, I can choose the bar chart. See here, this is a bar chart. For a bar chart, it is more appropriate. This is a bar chart, it's a more appropriate. See here, I can take it and then again I can show it here. See here, bar chart. 2016, 14, 15, 16, 17, how much value? Like I can increase the levels also, or I can decrease the levels also. So the purpose of this date here, declaring it as a discrete variable, is in the bar chart process. When you would like to go in with a line chart, order is a matters, chronological order is a matters. That is why the order date has to be declared as continuous. In Tableau, we have to declare, but there is no scope of declaring the value as a continuous variable or a discrete variable in Excel. But we have to choose appropriately which chart we are supposed to take up. Okay, right. With this, I am stopping, and tomorrow let us start with line chart with the prediction. Okay, prediction, and subsequently we can move with the line charts with the different application part also. And today, to summarize, we learned the concepts, dimensions versus measures, then discrete versus continuous, absolute versus relative measures, scales of measurement, nominal, ordinal, interval ratio. We have learned how to classify, how to differentiate. We have learned, followed by pie chart, pie of pie chart, simple bar chart, clustered bar chart, stacked bar chart, 100% stacked bar chart, and line chart we have covered. Okay, and please ponder over the presentations what I am using it. I will share it with SAR. SAR will distribute to you. The Excel working file also will share it to you, and the Tableau file what I am showcasing or demonstrating, that also I cannot share as a file, but I can share the link, that link through which you can go to the website and you can see that file. You can open it in the browser and you can visualize it in your system. So tomorrow evening I will share the link of the Tableau Excel file and the presentation file. Now I am requesting all